So today I want to talk about quantification, which is one of the fundamental ways that we can express ideas about the world and about math. And I specifically want to talk about the two most common flavors of quantification, universal and existential. And universal quantification is like when you say for all, and existential is when you say there exists. So let me give you an example, and this video is basically going to be a bunch of different examples so that we can get comfortable with these notions. So a really simple example would be all dogs are animals, which is an English sentence, and it expresses something that has the word all in it. And if I was going to formalize this mathematically, try to write it in the same way that mathematicians write universal statements, I might write something more similar to this. For all things, bear with me for a sec, for all things x, if x is a dog, then x is an animal. And that's because when I write it this way, I've got this for all sitting out in front. I got this for all things x. And this is something that's mathematically written with this symbol. This is for all x. Whereas we use this symbol for there exists an x. This is an upside down A for all, and this is a backwards E for exists. So the simple sentence, all dogs are animals, is rendered in a more mathy way as, for all things x, if x is a dog, then x is an animal. So if I take anything, if it's a dog, it must be an animal. So it captures the same idea. And this in turn then is written, for all x is a dog, implies x is an animal. So now I'm not talking about traditional objects in math. This is dogs and animals rather than numbers and sets and so on. But the same idea carries over if I go into a more mathematical setting. For example, I might want to write something down like every prime number greater than 2 is odd. And again, I've got a kind of a universal quantifier here. And so I might write this mathematically as for every x, if x is prime and x is greater than 2, then x is odd. So I've taken this English sentence and I've written it with a universal quantifier to capture the fact that we're talking about everything, either all dogs or every number. So for every x, if x is prime and x is greater than 2, if these two things are both true, if I pick a prime number which is greater than 2, no matter what it is, it must be odd. Now, even the concept of prime is something which involves quantification. So, what does it mean to be prime? X is prime. What this really means is whenever x is equal to a times b, either a equals 1 or b equals 1. It's exactly what a prime number is a number that you can't factor it unless one of the two factors is 1. There's no way of splitting it up into two factors that aren't trivial in the sense that one of them isn't 1 and the other one is just x. And this statement is, again, has this whenever part, and whenever is another way of expressing universal quantification. So this is all y, and for all z, if x equals y times z, then either y equals 1 or z equals 1. So what we're saying here is x's prime means for any two numbers, if they multiply together to give x, one of them must be 1, at least one of them. Now all of these examples have involved universal quantification, and existential quantification is now just telling me not that all things have a property, but that at least one thing has that property, right? So I might have a sentence like, some number is both prime and even. And this is a true sentence as well because 2 is a number which is both prime and even. And a way to translate this into math would be there exists an x such that x is prime and x is even. And we've already seen that this x is prime part can be given its own statements, its own sort of formalization in terms of quantifiers. And in fact, x is even can also be given its own statement in terms of quantifiers. X is even. For another example, what does this mean? To be even, then the requirement to be even is that you're twice some number. And here, this word sum is functioning as an existential quantifier. It's saying there exists a y, there's some number y, such that x equals 2y. This is a formalization of what it means for x to be even. It's even if there is some y that x is equal to twice y. Let me end with a couple of examples of having more than one quantifier of different types. So here's a statement in math. Here's a statement about natural numbers. So every natural number has some number bigger than it. So this is the statement, every natural number, so this is for all x, if x is a natural number, then it has some number bigger than it. So then there exists a y such that y is bigger than x. So this is to say every number, every x, if it's a number, then there's some, if it's a natural number, then there's some y which is bigger than it. And something that we sometimes do is we pull this domain of quantification, the thing that we're trying to quantify over here is numbers, is we pull it into the quantifier to write things more succinctly. So we write, for all x and n, for every natural number n, there exists a y, also a natural number, such that y is greater than x. And this is another true statement. Every number has something that's bigger than it. And we have two quantifiers in a row here, a universal quantifier followed by an existential quantifier. And what's interesting to note is that if I reverse the order, so if I write the same statement except I put the existential quantifier out front, what is this saying? This is saying there is a number, there is some natural number, such that for every natural number, x is below it. And this is false. This is saying there is a highest number, because it's saying everything else is below it. And this is, of course, false. Whereas this one was true. So the order of quantification really matters. This is saying for any x that I choose, I can find some larger y. And this is saying I can find a y up front which is higher than everything, which is, higher than every other number at once. So this is a primer on universal and existential quantification and the different types of statements you can write down using those symbols.